Today we will discuss about Wolff-Kishner Reduction reaction and Clemmensen Reduction reaction. We will see the difference between these two reactions and then previous year question that asked on Wolff-Kishner Reduction reaction. This is very important topic for GPAT and NIPER examination because one of the most repeated from topic in previous year GPAT examination. As we know that reduction is the process where loss of oxygen or gain of hydrogen or gain of electron is taking place, while oxidation is completely opposite to the reduction where loss of hydrogen or loss of electron or gain of oxygen is taking place. And this is the Wolff-Kishner reduction reaction where this carbonyl functional group or this carbonyl carbon of this ketone loses their oxygen and gain the hydrogen atom, so reduction is taking place here. This is the reaction where carbonyl functional group of the aldehyde or ketone converted into the methylene, that is CH2 group, and the product form is alkane. Starting aldehyde or ketone converted into the alkane on reaction with hydrazine and strong base KOH. For more detail of Wolff-Kishner reduction, how it works, if you see here, this is the carbonyl functional group of the ketone which condenses with the hydrazine and gives the intermediate, that is hydrazone. This hydrazone intermediate on reaction with strong base KOH, this KOH induces the reduction of this carbonyl carbon and oxidation of this hydrazine moiety. This carbonyl carbon is bonded with the carbonyl oxygen in starting material, but if you see the product, this carbonyl carbon losing their oxygen and gaining the two hydrogen, that is reduction is taking place at this carbonyl carbon, while this hydrazine moiety which is bonded with the two hydrogen, this nitrogen bonded with two hydrogen, but after oxidation it loses the hydrogen and only nitrogen gas is releasing in reaction as a byproduct. So oxidation of hydrazine moiety is taking place and reduction of carbonyl carbon is taking place in Wolff-Kishner reduction. The carbonyl functional group of aldehyde or ketone on reaction with hydrazine giving intermediate known as hydrazone. That hydrazone on treatment with the strong KOH strong base alkane is forming as a product and nitrogen is releasing as a byproduct. Main difference in the starting material and product is the carbonyl functional group converted into the methylene group, that is very similar to the Wolff-Kishner reduction reaction is Clemmensen reduction reaction where aldehyde or ketone is converted into the hydrocarbon, that is alkane, and carbonyl functional group mainly converted into the methylene, that is CH2 group, but the reaction condition is changed where here ketone or aldehyde reacts with zinc amalgam in presence of strong acidic, that is acidic condition, which is provided by the strong or concentrated HCl. The product form is alkane or hydrocarbon. The change in the reactant and product is only this carbonyl functional group converted into the CH2, that is methylene group. If you see the difference and similarity between the Wolff-Kishner reduction and Clemmensen reduction, in both the reaction, aldehyde or ketone are converted into the alkane or hydrocarbon. Change is only one thing, that is carbonyl functional group converted into the CH2, that is methylene group. But the difference is reaction condition. In case of Wolff-Kishner reduction, ketone or aldehyde reacted with the hydrazine in presence of strong basic condition which is provided by KOH, and product form is alkane or hydrocarbon. In Clemmensen reduction, aldehyde or ketone is reacted with zinc and amalgam in highly or strongly acidic condition which is provided by concentrated HCl, and the product form is alkane or hydrocarbon. This Clemmensen reduction mainly used for the starting material which is acid, which is base labile. Those ketone or aldehyde can be degraded by the strongly basic condition of Wolff-Kishner reduction are reduced by using the Clemmensen reduction. And conversely, if starting materials are highly degradable or susceptible to the acid such as HCl, then in such a condition, such a starting ketone or aldehyde are reduced by using the Wolff-Kishner reduction reaction. Because Wolff-Kishner is using base, Clemmensen using acid. If ketone are acid labile, then basic condition are used which is in Wolff-Kishner. So for acid labile ketone, Wolff-Kishner reduction is used. For base labile ketone, Clemmensen reduction is used. Some modification has been done by Hong and Millon scientists in Wolff-Kishner reduction in order to reduce the time for the reaction to proceed and get the better yield. That modification are use of ethylene glycol along with the hydrazine and strong base KOH in Wolff-Kishner reduction. That ethylene glycol which is used as a solvent along with hydrazine and KOH helps to remove the nitrogen gas which is formed in Wolff-Kishner reduction as a byproduct. That removal of nitrogen is helpful and or facilitate the reaction and reduces the time that required to get the final product. So this is the main difference between the Clemmensen and Wolff-Kishner reduction. Clemmensen reduction uses the strongly acidic condition by HCl, and Wolff-Kishner reduction uses the strongly basic condition provided by KOH. Clemmensen reduction is used for base sensitive ketone, and Wolff-Kishner reduction used for starting material that which is susceptible or sensitive to the acid. This is the previous year question on Wolff-Kishner reduction. Here reaction is given, product is here whole reaction is given and the name of reaction is asked. This is the ketone and which is reacting on hydrazine forming intermediate hydrazone on treatment with strong base KOH converted into the alkane or hydrocarbon. So we know that ketone is only converted into the alkane. This carbonyl functional group is converted into the methylene group, and this possible by two reactions, Wolff-Kishner reduction and Clemmensen reduction. But Clemmensen reduction, we know their acidic condition provided by HCl is used and zinc amalgam is used as a reducing agent. In Wolff-Kishner, we know that hydrazine is used and strong base KOH is used. So this is the Wolff-Kishner reduction reaction, and option C is correct. In second question, here starting material and product is given, and which conditions can be used for conversion of this starting material ketone into alkane can be used is asked. So here we know that ketone, here carbonyl functional group is converted into CH2 methylene group. All remaining part is same. So we know two reaction conditions are used. Clemmensen Reduction, where zinc amalgam and HCl can be used, and Wolff-Kishner, where hydrazine and strong base such as NaOH or KOH can be used. But we know the difference between Clemmensen reduction and Wolff-Kishner reduction. Wolff-Kishner reduction used for acid labile compound, and Clemmensen reduction used for base labile compound. So this is the acid labile compound. So Clemmensen reduction can't be used here, but Wolff-Kishner can be used to convert such acid labile compound into the ketone. So option C is correct for this reaction or this question. So this is the third question where starting material is given, reaction condition is given, and which product will form is asked. This is the GPAT 2020 question. Here if you see, this is the ketone functional group or carbonyl functional group of the ketone, and which on treatment with the hydrazine and base. We know that hydrazine and base are used to convert the ketone into the alkane, and change happening is only on carbonyl functional group, which is converted to CH2 group. If you see the all option here, CH2 group is only present in option 2, so option 2 is correct answer for this question. If you see this Wolff-Kishner reduction and Clemmensen reduction, the changes happening only carbonyl functional group is converted into CH2 group. So here also change should be here only. So if you see here, change is correct here, and carbonyl functional group is converted into CH2, that is methylene group. So option B is correct, and this reaction is Wolff-Kishner reduction reaction. Similarly, sometimes Clemmensen reduction is also asked in GPAT and NIPER examination. So both the reaction are very important, and you should know the difference between these two reactions and what exactly is happening in the reaction. That is aldehyde or ketone carbonyl functional group converted into the CH2, that is methylene group. If you like the video, share with your friends and subscribe our channel for getting updates of new videos on chemistry for GPAT and NIPER preparation. And thank you for watching the video.